morning, myself Sri Lakshmi. Today I am here to give you a small information or a small introduction about real numbers, its classification, finding the absolute value of a real number, the distance between two real numbers, and of how to find the midpoint between two real numbers. So, talking about real numbers is a system that constitute all type or all kind of numbers apart from imaginary numbers. Actually, real numbers is a system or a collection of all type of numbers that may include natural numbers, whole numbers, fractions, decimals, irrational numbers, and every kind of numbers. So, when we look into the classification of real number, a real number or real numbers can be divided into two parts, that is irrational number and irrational number. Actually, real numbers are the union of or the collection of the rational numbers and irrational numbers. So, what is a rational number or what is an irrational number? Rational number is nothing but a number is said to be a rational number if it can be expressed in a fractional form p by q, where p and q are integers and q must not be 0, that is q not equal to 0. That means a rational number or any number can be defined, or any number can be told to be a rational number if it can be expressed in the form of p by q form. That is a number that can be written in the form of p by q. That the number having a fractional representation p by q, where p and q are integers and q not equal to 0, is called rational numbers. And coming to the irrational numbers, it's like entire opposite definition for that. That is nothing but the number that cannot be written in the form of p by q. That is, we cannot express that number. We cannot give the decimal representation, the fractional representation p by q for that number. For p by q, where p and q are integers and q not equal to 0, if we cannot write that number, then that number can be defined as a irrational number. So it is a basic difference between rationals and irrationals. So it's nothing but a number that have a fractional representation p by q is called rational number, and does not have a representation p by q is called irrational numbers. So looking into those rationals and irrationals, which numbers are told to be rational and what are the numbers that includes in irrational? Rational numbers, that every kind of numbers, like natural numbers, the number system starting from 1, 2, 3, etc. and goes on, and whole numbers, the number system starting from 0, the integers, the numbers having negative and positive sign, fractions, decimals, all these kinds of numbers belongs to rational numbers. Then what are the numbers that belongs to irrational number? Yeah, it is the numbers that are not having square root or that remains inside the root, inside the square root, are mainly inside or mainly belongs to irrational numbers, like that number root 2, root 3, root 5, etc. These numbers does not have a square root because they are not perfect squares, so they always remains in the root, right? So these numbers includes irrational numbers. These numbers constitutes irrational numbers, the system irrational number. So irrational numbers are nothing but the numbers mainly having square roots. That like if you have write its decimal representation, its number does not stop at anywhere. It will, after the decimal point, it will go continuously goes on without any ending. So these kind of numbers, numbers having root without having any square root, that still consisting inside a root, are considered as irrational numbers. So is root 4 is a rational number? Definitely not. We know that 4 is a square, perfect square. So root 4 is 2, so it does not belongs to irrational number. It is a rational number. Now, there's another important fact about irrational number is that we all heard about number pi, right? When we use that symbol mainly while finding the area and perimeter of the circles. In circle measures, we are mainly dealing with number pi. We know that the pi have a decimal representation 3.14 and a fractional representation 22 by 7, right? So, but pi is not a rational number. It is a rational number. Okay, we all know, since pi is a number with having a fraction representation where 22 and 7 are both integers and 7 are equal to 0, and it also has a fraction representation decimal representation 3.14, even though the number pi is considered as a irrational number. So these are the basic idea about real numbers. Real number is nothing but the collection of both rational and irrational numbers. So now looking into the concept real line. What is a real line? Now Talking about real number line, a number line, or simply a real line. Real line is a line with integers that is extending on both sides. That is, the zero is considered as a midpoint of the line, and we can see that numbers or integers are returning both sides, which is equidistant. They are equidistant from each other. So this is a number line. Real line is nothing, or number line is nothing but a line that is extending both sides, containing integers and zero as a midpoint. From zero to right sides 1, 2, 3, 4 is going to infinity, and to the left side it's -1, -2, -3 is going to the negative side to the infinity. So this real line is a system. It's a line that representing the numbers, real numbers. So while we are drawing a real line in a page or representing, we only use integers to represent those right in the line. We does not include all kind of real numbers inside the line. We only mention the integers and express using the integers. So real number line is a line with these integers, and each of the integers are placed in equal distance, and between the integers all kind of real numbers exist, like rational numbers, irrational numbers. So everything can be marked inside the real line. So other numbers in between numbers on the line represent rational, irrational, and other types of real numbers. Such a line with points labeled using real numbers, that is, a real line where the points are labeled using real numbers, are called a real number line. Moving on to the next topic, absolute value. Absolute value or modulus value of a real number is really simple concept for us. It's nothing, we know that we haven't heard about this term before, but the term absolute value, the concept is very simple. It's nothing but absolute value of a real number, x. This x is, we generally called it as whatever number it is, whether it is a negative number, non-negative number, is a fraction, is a decimal, is a rational, whatever the number it is, the absolute value of that number is a non-negative value of the number without regard of its sign. That is, whatever the number it is, the absolute value of that number is a non-negative number. That is, for a number 2, the absolute value of 2 is 2 itself. The non-negative value of 2 is 2. And for -2, the when it takes non-negative value, the negative sign will be cancelled. So it's 2. The absolute value of -2 is also 2. So its absolute value is nothing but it's a non-negative value of a number itself is called absolute value of a number. That is, for a positive number, the absolute value of the number is same itself, since we know that positive numbers does not have any negative sign. So for a positive number, the absolute value of the number is that number itself. And for a negative number, the absolute value of the number is the negative of the number. That is, if x is a if x is a negative number, then if we take the modulus, or if we find the absolute value of the number, then we have to take the negative of the number, that is negative of negative x. That is, if we have to find the modulus value of -2, then modulus of -2 is negative of -2, and minus and minus get cancelled and answer will be 2, right? So the absolute value of a number, for a positive number, we can define it in three ways. That is, the definition consists of 3 steps. That is, for a positive number x, the absolute value of the x will be x itself, or the number itself. For 0, then absolute value is 0 itself. And for a negative number, the absolute value of the number is the negative of the number. The cases are 3. We have 3 cases are there. So this is the definition about the absolute number. So now let's look into a small problem that explaining finding the absolute value of a number. Talking about the absolute value of a number, absolute value is usually we represent as drawing lines on the both sides of the number. That is, the modulus of the number or the absolute value of the number is we write like this. So as I told you earlier, when we use the definition of an absolute value, we have 3 cases, right? For x greater than 0, we know that the absolute value of a number is the number itself. That is, modulus of x is equal to x. And for 0, that is, for if x is equal to 0, the number is 0, then the modulus of the number, that is, the absolute value of the x is always 0, because we know that since 0 has no other signs, the absolute value of 0 is 0 itself. And for negative value, that is, if x less than 0, then the modulus value or the absolute value of x is the negative of that number. That is, we have to take the negative of the number that given, that is negative of x. So let's look into the more examples for that. That is for 2, we know that the modulus of 2 is always 2, right? So because since 2 is greater than 0, the modulus of that number, or the absolute value of the number, is that number itself. So modulus of 2 is 2 itself. And in the case of minus 2, modulus of minus 2 is nothing but what? We know for x less than 0. We have told you that if x is a negative number, or x less than 0, then the absolute value of x, or the number, is the negative of the number, right? So since negative 2 or minus 2 is a number which is less than 0, the modulus of minus 2 is the negative of that number. Since we know that this negative and this negative eventually cancel together and becomes 2, right? So for a number, if the number is positive, the modulus value of the number is the number itself. And if the number is negative, the modulus value of the number is the negative of the number itself. So this is all about the absolute value of a number. On the number line, the absolute value of a number is the distance between the 0 and the number itself. That is, this distance from the point labeling 0 and the point labeling that number is considered as the absolute value of that number. So we had talked about the term distance, right? So let's move into the topic distance. A distance between two numbers. How will we usually find the distance between two numbers? Yeah, we're just subtracting, right? We are just subtract the largest number, smallest number from the largest number, right? It's the same process here, but here we also, for the definition purpose, we also use the term absolute value for that. It's nothing but the distance between two numbers x and y in a number line is nothing but modulus of x minus y. That is, we have to find the difference. Where it is x minus y minus x, just take x minus y. We just subtract y from x, for second number from first number, and take the modulus value. Actually, we know that the difference between two numbers are basically, we just subtract the smallest number from largest number, right? So if we find the distance between 5 and minus 2, we know that minus 2 obviously is the smallest number, right? So the difference between the minus 2 and 5 is just nothing but, we just need to subtract 5 from minus 2. That is minus 2 from 5. That is 5 minus 2, and the minus and minus eventually get plus, and 5 plus 2 is equal to 7, right? So it is a basic definition, or the basic method of finding the distance. But when it comes to the terms in absolute value, it's just nothing but just subtract both numbers and find the absolute value of that difference. That is the way to find the distance between two real numbers on a real line. So the distance of two numbers x and y on a real line is just x minus y, and find the absolute value, or just modulus x minus y. Into the concept distance, that I have already told you that distance between two numbers is just subtract the smallest number from largest number, right? So here, if we take the distance, or if we have to find the distance between minus 1 and 3, we just need to subtract what the distance is. Just subtract the smallest number from the largest number, which is the largest number, smallest number here. Yeah, it is minus 1, right? So we have to subtract the 3 minus from 3. That is 3 minus 1 is become minus, and minus eventually becomes plus. So 3 plus 1 is equal to 4. In other terms, we have to we have to find using absolute value. We know that if x and y are two numbers, then distance between x and y is a modulus of x minus y, right? So here we use that method. We can find it that modulus of x minus y is minus 1 minus 3, or you can take it 3 minus 1, whatever the case. We can choose any as x and y. There is no order for that. We just need to subtract it, right? Minus 1 from minus 3. That is minus 1 and minus 3 is what? It's minus 4. 4 becomes modulus of minus 4. We know that modulus of minus 4 is minus 4 is a negative number. Modulus of is a negative of the negative, that number, right? Negative of the number becomes 4, right? So in either way, we will get the right answer 4. Then from the line itself, it's clear that from minus 1 is 1, 2, 3, 4. Right. So, while finding the distance between two real numbers, either you can divide the either you can subtract the smallest number from the largest number, or you can just find the difference of the both number and take the absolute value of that difference. Now, moving on to the last topic of this session is about finding the midpoint on a real number line, or find the midpoint of two real numbers. So Finding a midpoint is a very simple method. It's just we have to find the sum of these two numbers, or the numbers that we have to find the midpoint. Just add those two numbers and divide it by 2. Just take the half of the sum. So the midpoint of two numbers in the number line is that the point that represents the half of the sum of the numbers which the points are marked on it. That is, we just need to take those two numbers, or the number x and y. We just need to add those two numbers, x plus y, and divide it by 2, or the find is half. So the midpoint of two real numbers is the half of the sum of those two numbers in the real number line. So if we have to find the midpoint of two numbers, 2 and 3, we just need to add those two numbers. 2 plus 2 is 5, and find the half of it. 5 by 2 is 2.5. So 2.5 is the midpoint between, or midpoint of 2 and 3. So the another type of section that occurs most commonly in this section is, or the other type of problem is, if a number and another number, if a number x and a number and x and another number have same distances are there, that is the distance from x to a first number and the x to and the second number are same, the distance between x and those numbers are same, then the value of x is actually the midpoint of these two numbers. So these types of problems that can be that are the most frequently asked questions in the session of midpoint. So just looking into the method of finding midpoint and finding the value of x if such cases are occurs. Now let's look into the finding the midpoint of two numbers. So as I already told you that midpoint of a number, or finding a midpoint of two numbers, is very simple, that we just need to add those two numbers and find the half of it. So in this number line, we know that the midpoint, when it comes to in true case, if we have to find the midpoint between -2 and 2, we just need to find the number that has the equal distance from both sides, right? So the distance from both sides, 2, two sides from here and 2 is from here, the midpoint is 0, right? So it's very easy to find from the real number line, or directly from the number line. But what if the case, if the numbers are very large for us? So for that we have to use the equation, and the equation is very simple. For example, you have to find the distance between 3 and 5. We have to do is that the midpoint is, how can we find the midpoint of 2 minus 3 and 5? It's very simple. We just need to add those two numbers, right? And then divide it with the 2, or find the half of it. So midpoint is adding -3 plus 5 and divided by what? 2. Also -3 plus 5 is how much? -3 plus 5. -3 plus 5 is what? Is 2, right? 2 by 2, and the number is what? -3 by plus 5, 2 is -3 plus 5 becomes 2, and 2 by 2 is 1. So the midpoint between -3 and 5 is what? It's 1. That is, here we can see that I am adding the 2 more points from here. So from -3, it is 1, 2, 3, 4 points from here, and from 5 it's 1, 2, 3, 4. Right. So 1 is the midpoint of -3 and 5. So while finding the midpoint of two numbers is very easy. Just add those two numbers and find the half of it.
And also, if they're given that the distance between x and a number is equal to the distance between x and the number, x minus suppose is 6, then the value of x, how can we find the value of x? The value of x must be the midpoint of 2 and 6. It is 2 plus 6 by 2. That is 8 by 2. That means what? 4. So in this case, in finding the midpoint, this case also occurs. That is, if the distance between x and a number, and x and another number is comes to be equal, that means the value of x is the midpoint of the other two numbers.
We reach at the final concluding section of this class. So in here we are discussed about the topic real numbers. The concept real numbers is major classification into rational numbers and irrational numbers, how they differ, what the basic definition regarding the rational numbers and irrational numbers. Then we look into the real number line, how they represent, and finding the absolute value of a real number, and the method of finding the distance between two real numbers, and finding the midpoint between two real numbers. We know that absolute value of a number is nothing but the non-negative value of the number, and the distance between number is the absolute value of the differences of those two numbers, or nothing but just subtracting the smallest number from the largest number, right? And for finding the midpoint of the real numbers is very simple. We just need to add those two numbers and find the half of it. So these are the main three concepts along with the real numbers that we had learned today. So I hope you like this class and understand the concept. Thank you.